Hello everyone, welcome back to our channel Problematical. Today we'll be discussing miscellaneous examples from chapter 12 in class 11th Maths NCERT. So example 11 states that show that the points A, 1, 2 and 3, B and C and D are the vertices of the parallelogram ABCD, but it is not a rectangle. So for a figure to be a parallelogram, provided its coordinates of the vertices are mentioned, we will have to prove that the opposite sides are equal. You have points A, B, C, and D. Always write these points in order of its mention. Like these will be either considered as cyclic or clockwise or anti-clockwise, but they'll always be considered as cyclic. So ABCD points are mentioned. You have to prove that AB is equals to DC and BC is equals to AD. So let's calculate these points. AB will be equal to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So A and B minus A, which is minus 1 minus of 1 whole square plus minus 2 minus 2 whole square plus minus 1 minus 3 whole square. This is equals to minus 2 whole square, which is 4, plus minus 4 whole square, 16, plus minus 4 whole square, 16. This will be equal to root 36, which is 6. DC value is equals to root of C minus D, which is 2 minus 4 whole square plus 3 minus 7 whole square plus 2 minus 6 whole square. Again, this is root of 2 square 4 plus 4 square 16 plus 4 square 16. This again is equals to root 36, which is equals to 6. So AD is equals to BC. Next, BC. Let's calculate BC again with the same formula. X2 minus x1 whole square plus root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. BC would be C minus B, which is 2 minus of minus 1, 2 plus 1 whole square plus 3 minus of minus 2, 3 plus 2 whole square plus 2 minus of minus 1, 2 plus 1 whole square. This is equals to root of 3 square 9 plus 5 square 25 plus 3 square 9. Right. Sorry. So nine plus 9, 18 plus 25, 43. AD is equals to root of 4 minus 1 whole square plus 7 minus 2 whole square plus 6 minus 3 whole square. This is equals to 4 minus 1 to 9 plus 7 minus 2 again 5, 25, 3, 9. This will be root 43. So from here we can see that BC is equals to AD. And from the initial two conditions we can see that AB is equals to DC. So from these two conditions we can say that ABCD is a parallelogram. Now, it is mentioned that you are also supposed to prove that it is not a rectangle. Now, we know that the difference between parallelogram and rectangle is the diagonals of a rectangle are equal. However, diagonals of parallelogram are not equal. There's a bigger diagonal and a smaller diagonal. The diagonals of parallelogram and rectangle both, they bisect each other. That's true. But here you have a bigger diagonal and a smaller diagonal. Let's calculate these diagonals. If the diagonal values are equal, it is a rectangle. If they are unequal, it's a parallelogram. So now you're supposed to calculate AC and BD. AC. Your AC is equals to, your AC will be equal to root of C minus A. So 2 minus 1 whole square plus 3 minus 2 whole square plus 2 minus of minus 1, sorry, 2 minus 3 whole square. This is equals to root of 2 minus 1, 1 square, 1 plus 1 square plus 2 square, which is 4. So this is equals to root 6. 2 minus 3 is 1, sorry. 1. This is equals to root 3. Next, you're calculating BD. BD is C minus B, which is 4 minus of minus 1, which means 4 plus 1 plus 7 plus 2 plus 6 minus 1 plus 1 whole square is equals to 4 plus 1, 5 square, 25 plus 7 plus 2, 9 square, 81 plus 6 plus 1, 7 square, 49. So adding them, we get 155. Clearly, the AC is not equals to BD based on values. Therefore, ABCD is not a rectangle. Next, find the equation of set of points P such that the distances from the points A and B are equal. Now, this type of question we've already done in the exercise. You have these endpoints given to you: A, 3, 4, minus 5, and B, minus 2, 1, 4. And you have to find the equation of points P. So P can be any point which is dividing this AB in the ratio k is to 1, and let the coordinates of P be x, y, z. It's given that the distances are equal. So instead of mentioning it in terms of ratio, it's given that they are equal. So the ratio would be 1 is to 1. Or we can say that AP is equals to PB. This is when the distances from point distances of this point P from A and B are equal, or PA and PB, or P is the midpoint of AB, or P is equidistant from A and B. This is all three mean that M is to N is 1 is to 1. Now, AP is equals to PB, its square will also be equal, because if we apply distance formula now, you'll get a root term on both sides. Taking square, this root can be eliminated. So your AP square will be equal to PB square. This is true, then your root gets nullified and you're left with applying a distance formula: x minus 3 whole square plus y minus 4 whole square plus z plus 5 whole square minus of minus 5 is equals to x minus of minus 2, x plus 2 whole square plus y minus 1 whole square plus z minus 4 whole square. So you have x square minus 6x plus 9 plus y square minus 8y plus 16 plus z square plus 25, not 25, 5 into 2, plus 10z plus 25 is equals to x square plus 4x plus 4 plus y square minus 2y plus 1 plus z square minus 8z plus 16. So now we'll cancel it out. Whatever is cancelable, definitely x square, y square, z square. What else? You have 16 can be cancelled. Anything else? X, y, z? Nope. So let's write the remaining terms, whatever we are left with. We have minus 6x. We'll write the variables first, and we'll take all the variables from the right hand side on the left side. So minus 6x, let's do that in the next step. Minus 6x minus 8y plus 10z. The variable terms first, then plus 9 plus 25 is equals to 4x minus 2y minus 8z plus 4 plus 1. Taking everything on the left hand side. Now 4 plus 1 is 5. If you subtract it over here, you'll get 20. 20 plus 9 is 29. Minus 6x minus 4x. Minus 4x. Then minus 8y. Here you have plus 2y plus 10z plus 8z plus 9 plus 25 minus 5. 4 plus 1, 5 is equals to 0. This would be 20 plus 9, 29 plus is equals to 0. You have 18z. You have minus 6y. Then you have minus 10x. You can multiply with minus 1 on both sides and get 10x plus 6y minus 18z minus 29 is equals to 0. Okay. Next question. The centroid of, so this was the equation of the set of points P. The centroid of a triangle ABC is at the point 1, 1, 1. So let's draw a triangle first. A, B, C. Centroid of the triangle, if the coordinates A and B are 3, minus 5, 7. B would be minus 1, 7, minus 6. And C you're supposed to calculate, which is x, y, and z. C is the centroid. Let's see, we over here. Sorry, centroid is given. So let's consider with another variable. D is a centroid, and its coordinates are 1, 1, and 1. Now, there's a formula which connects your centroid with the other points, vertices, if all coordinates are mentioned. We know that for a centroid, x4, y4, z4, your x4 will be equivalent to x1 plus x1 plus x2 plus x3 divided by 3. y4 will be equal to y1 plus y2 plus y3 divided by 3, and your z4 will be equal to z1 plus z2 plus z3 divided by 3. Therefore, your x4 will be equivalent to 3. In this scenario, your x4, y4, z4 is 1, 1, 1. So, equating that, 1 will be equal to 3 minus 1 plus x divided by 3. 1 is equals to minus 5 plus 7 plus y divided by 3. 1 is equals to 7 minus 6 plus z divided by 3. Therefore, your x is equals to 3 will get cancelled, positive 1, 3, or y is equals to 3 minus 2, which is equals to 1, and your z is equals to, you have 3, 7 minus 6 is 1 plus z, which implies z is equals to 2. So, coordinates of C are 1, 1, and 2. Thank you.